The journey from abstract logic to physical reality follows a purposeful progression, moving from the microscopic rules of the derivation sheet to macroscopic laws of the universe. This narrative, reflected in both the state and sequence diagrams, illustrates how we transition from theoretical rules to practical proofs. The foundation: abstract logic. The process begins at the level of the derivation sheet, where the fundamental rules of vector calculus are established. At this stage, the focus is entirely on the internal logic of how different operations interact. By proving that certain combinations of swirl and slope always result in zero, the derivation sheet provides the rigid mathematical scaffolding upon which all physical interpretations are built. Local interpretation: from rules to stories. As the state diagram suggests, the first major transition is from theory to local physicality. Here, the zeros found in the derivation sheet are translated into human-scale analogies. For example, the mathematical impossibility of a certain swirl is described as the uphill paradox, the idea that you cannot walk in a continuous circle on a mountain and always be moving upward. Similarly, other identities are interpreted as the net flow logic, where swirly motions are seen as continuous loops that have no beginning or end, much like the path of magnetic field lines. Visual illustration: seeing the invisible. The sequence diagram then moves this conceptual understanding into visual demonstration. Using digital tools, these abstract stories are turned into visible fields. We see irrotational fields as arrows radiating straight outward, like steam rising from a kettle, showing a flow that expands but never spins. We also see solenoidal fields as perfect circular vortices, showing motion that spins intensely but never grows or shrinks in volume. These visualizations bridge the gap between a written proof and a physical mental model. Global expansion: the big picture. The progression then shifts from what is happening at a single point to what is happening across an entire area or volume. This is the big picture stage, where local properties are linked to global conservation laws. The rules from the derivation sheet are used to explain why the total work done in a closed loop must be zero, conservation of energy, and why magnetic field lines can never simply stop at a point, Gauss's law for magnetism. Rigorous verification: the final confirmation. The narrative concludes with numerical verification, where the abstract and the visual are tested against hard data. By calculating the flow through a surface and comparing it to the activity inside a volume, such as measuring a square surface or a cube, we can prove that the two sides of these complex laws balance perfectly. Finding that both measurements result in the exact same value, such as a consistent 2.0 or 3.0, provides the final, practical confirmation that the microscopic rules established on the derivation sheet accurately govern the macroscopic world.